A servo motor is how a machine moves to an exact spot and knows it got there. A robot arm reaching a weld point. A CNC axis holding a thousandth of an inch. A packaging head placing a label in the same place every time. None of that is luck. It is a servo closing a loop hundreds of times a second. In this video, I will show you what a servo actually is. The closed loop that makes it precise and why it beats a stepper when the job is hard. By the end, the word servo will stop being a mystery. Quick note before we dig in. This is from PLC Simulator. You can practice robot and motion programming free in your browser. Write real motion code and watch a simulated arm move. The link is in the description. Now, let's open up the servo. So what is a servo? A servo is not one part. It is three parts working as a team. There is the motor, which makes the torque and the motion. There is the encoder bolted to the back of the motor, which measures exactly where the shaft is. And there is the drive, the controller that reads the encoder and decides how hard to push the motor. Motor, encoder, drive, together they form a closed loop. Compare that to a stepper motor running open loop. A stepper just takes the steps it is told and hopes it arrived. It never checks. A servo always checks. That feedback is the whole difference. Here is the loop, step by step. You give the drive a commanded position, go to 90 degrees. The drive sends current to the motor, and the motor starts turning. The encoder reports back the real position, moment by moment. The drive compares the two. Commanded minus actual is the error. If the error is large, it pushes harder. As the shaft closes in, the error shrinks and the push eases off. When the error is basically zero, the motor holds. And it keeps holding. If something nudges the shaft, the encoder sees the error and the drive corrects it instantly. That correcting loop runs thousands of times a second. That is why a servo lands on target and stays there. So when do you reach for a servo, and when is a stepper fine? A stepper is cheap, simple, and open loop. It has strong holding torque at a standstill. And for light, low speed, predictable jobs, it is perfectly good. Think a 3D printer or a small indexing table. But push a stepper too fast or too hard and it can lose steps silently, and you will never know it drifted. A servo costs more and needs tuning, but gives you real feedback, high speed, high torque under load, and accuracy that holds. The rule of thumb: cheap, slow, and predictable, a stepper. Fast, heavy, or precise where missing matters, a servo. Where do you actually meet servos? Everywhere precise motion lives. Robot joints, CNC axis, conveyor indexing, flying shear cutting on the move, pick-and-place heads. And here's the part that matters for us. You rarely command a servo by hand. A PLC commands it. The PLC fires a motion instruction, a move to, or a velocity command. It sends it to the drive over an industrial network like Ethernet/IP or Profinet. The drive runs the closed loop locally and reports position back. So the PLC says where to go, and the servo handles how to get there precisely. That handoff is the heart of modern motion control. So let's pin it down. A servo is a motor, an encoder, and a drive in a closed loop. The loop compares commanded to actual, corrects the error, and holds. A stepper is open loop and cheaper. A servo is closed loop and precise. And a PLC commands the servo over a network. Get those 4 ideas, and you understand servo motion. Now, go make it concrete. The best way to understand closed-loop motion is to drive it yourself. You can practice robot and motion programming free in the browser. Write real code, run it on a simulated arm, and watch it move to position. Click the link in the description to start free at plcsimulationsoftware.com. Subscribe. New video every Tuesday. See you in the next one.